Types of tree data structures. There are several types of tree data structures, each designed for specific use cases. We will just list out types of trees here and we'll learn one by one in detail in upcoming videos. The first one is binary tree. It is a tree where each node has at most two children, referred to as their left and right child. The next type is binary search tree, a special type of binary tree where the left child contains values less than the node and the right child contains values greater than the node. The next type is AVL tree. It is a self-balancing binary search tree where the height difference between the left and right subtrees of any node is at most 1. It ensures we go of log n time complexity for insertion, deletion and searching. Next type is red-black tree. It is a balanced binary search tree where each node has an additional color attribute, either red or black, to ensure the tree remains balanced after insertion and deletion. The tree ensures big O of log n operations for searching, inserting, and deleting. The next type is B tree. It is a self-balancing tree data structure that maintains sorted data and allows searches, sequential access, insertions, and deletions in logarithmic time. Commonly used in databases and file systems. The next type is heap. It is a complete binary tree that satisfies the heap property. In max heap, parent nodes are always greater than or equal to their children. In min heap, the parent nodes are always less than or equal to their children, typically used to implement priority queues. The next type is trie, also called prefix tree. It is a tree used to store strings where each node represents a character of a string. It is widely used for efficient retrieval of key in dictionaries such as autocomplete systems. Next type is segment tree. It is a tree used for storing intervals or segments. It allows answering range queries efficiently like sum, minimum, maximum, and can also be updated dynamically. The next type is Fenwick tree, also called binary index tree, a data structure that provides efficient methods for calculating cumulative frequencies or sums and supports updates in logarithmic time, often used in scenarios like frequency analysis and range queries. The next type is suffix tree. It is a compressed tree that represents all suffixes of a given string. It is mainly used in string processing algorithms for pattern matching and finding the longest common substring. The next type is k-array tree. It is a tree where each node can have up to k children. For example, a 3-array tree allows each node to have up to 3 children. The next one is spanning tree, a subgraph of a connected graph that includes all vertices with minimum possible number of edges forming a tree, commonly used in network routing algorithms. The next one is binary heap, a binary tree based data structure where every parent node is either greater than or less than its children. The last one is ternary tree. It is a tree data structure where each node has at most 3 children.